Okay, good morning, everybody. It is actually the Saturday morning, the 19th of September, 2020, as I record this. Um, Getting a jump on things Saturday morning, nice and early. Um, okay, this week's topic is data visualization. Even though the assignment really makes you just talk about Python and R. I'm going to offer an alternative for those that are listening carefully to this video. So let's get started. Here's our overview. I have some uh, general, generalized feedback for everyone as a group. We're going to talk about some principles of data visualization that apply to every tool, every type of visualization out there. I'm going to show you a little Tableau. Tableau is a software tool that is being used, I would say, just about. I think they have the majority of the market share when you look at different polls out there. Um, I'm going to show you a Python chart, but there's also a lecture. I interviewed a colleague of mine um, to talk about R programming. So we've got a little bit of Python and a little bit of R to look at this week. I wanted to talk to you about the residency weekend, which is coming up in 2 weeks, October 2nd through the 4th. And again, give you a choice as a group. I can't do, individual stuff, but I've got a survey I want you to take that's in the folder for week 5 to see what you prefer for your residency weekend assignment. And then I'll briefly go over the week 5 discussion, which again is really just asking you to compare R and Python. Um, so this next chart, it says week 2 research papers, but I just wanted to make some um, another plea. Some of you are headed for a failing grade. Others are doing very well. So my words of warning don't apply to every student. So please forgive me if these comments don't apply to you. But I'm seeing evidence of I don't know if it's just lack of confidence or if it's intentional cheating. I'm not sure, but I'm seeing too many examples of poor work for doctoral students. You guys should, as a group, every one of you should be operating at a fairly high level, and some are not. And I'm just trying to improve that. I saw several papers that started with not the template I provide, but some other paper that used headers that were left justified and had a colon after them, which is not APA format. And it was obvious that the root template was both incorrect and was shared or used by multiple students, which is always problematic. You guys need to be working independently. I mean, you can get together and discuss these topics certainly as a group, but when it comes time to creating work product, you need to be working independently, and that includes relying on strangers from the internet, as I've talked about, Course Hero and whatnot. Um, Many of the papers were really more of an overview. They don't attack the specific assignment instructions, which again is a sign of using some other paper that's not focused on the instructions generally, and um, trying to turn something in that looks good without I'm still seeing paraphrasing website output in papers and discussion. Still seeing large information. Uh, you know, I saw the term huge statistics, something as its source for huge statistics, which is just that's what an article spinner says when it sees the term big data. Um, So it's disgusting, guys. You need to realize this. Um, Using article spinners and other papers, and just not doing your own uh, good, honest, hard work. It's terrible. It shows a lack of character, and I'm sure the university would back me up on that, being a moral, ethical, Christian-based university. And again, I'm seeing the Dr. Frankenstein approach to assembling papers. You're taking, the dead body parts, some of you, the dead body parts of other papers, and changing a few words and sticking sentence by sentence in. And I would challenge you, certainly none of you are native English speakers, but I would challenge you to be a little more brave and write originally. You know, delete everything out of the template paper and create your own headers, create your own paragraphs. Start with an outline, like I keep telling you. I can see that you're not doing it, and it breaks my heart, really. You've got to be going through so much effort, um, and it's misguided effort. It's misdirected. If you would just start from an outline and come up with your own thoughts, your own thesis sentence, your own um, uh, topic sentences for your paragraphs, and don't forget a conclusion paragraph. You have to have a conclusion paragraph. So yeah. Anyway, there you go, guys. So this week's topic, data visualization. I got quite a bit of material to go through here. Hopefully, it won't take more than an hour. Data visualization. And we'll get into uh, some of these psychological concepts here in a little bit. It turns these numbers that just look like numbers into something the human brain can actually pull in and digest. Um, the article this week, I think, might have been translated without a native English speaker editing it or giving any feedback, and it's really not well written. Okay, guys, when you read this paper this week, I want you to realize that as an academic writer, college professor, native English speaker, that paper is not well written. It's informative when when you read it, but it's not well written. Okay, so one of the examples is where they say data visualization techniques are authenticated scientifically as thousand times, which is grammatically incorrect. It would be as a thousand times more reliable. See, this is sounds like something, and even an article spinner would give you better grammar than this. But data visualization techniques are authenticated scientifically as thousand times reliable rather than textual representation. And what that is a horrible way of saying the old saying, a picture is worth a thousand words. You see that? The difference? Um, it's just, yeah. So anyway, there are many examples of visualization that you guys see in your daily lives and in your professional lives. Sometimes you don't even realize, like if you live in a metropolitan area and you look at a subway or metro map, that's a visualization. Um, and then you've got everything from the most simple graphs, like pie charts and histograms and column charts and scatter plots and whatnot. The all the way up through, if any of you've seen Minority Report with Tom Cruise, maybe what, 10 years ago, and some other cutting edge. If you're out there on YouTube, you'll see these cutting edge interactions, which are a combination of data visualization, virtual reality, 3D, where you can, using your virtual reality interface, you can spin things around and go into and out of a data representation that's not an actual real world object. But it is a representation of the data that when you look at it visually, um, it, it, it makes more sense than it ever would as just being columns of numbers. And then there's lots of visualization techniques out there, or visualization tools out there, as far as creating these, dashboards and infographics and whatnot. Power BI from Microsoft and Tableau are the ones you see the most common. But there's I know a guy who works with a software tool called Domo. If you're a web developer, there are JavaScript libraries out there that allow you um, to do some awesome things with your data, creating interactive websites. One I heard about saw recently was called data driven documents. I think it was D3 was their URL. Um, and you're increasingly you're seeing visualization become interactive, so that when the user sees it, they're not just seeing a static chart, but they're actually able to go, well, gosh, that's interesting, and what about this variable, or what about this factor, or they can drill down and back up through the data. So that interactivity is getting to be, as computers and data analysis software um, becomes more mature and more available, you see a lot more of that sort of stuff. So I provided links to a tutorial on Gestalt and Tufts principles. So I want to go over here and talk about these. These are general purpose. Uh, Here's the a tutorial. There are many treatments of Gestalt principles, but uh, it's the way the eye tells the mind what's going on, and then it's been um, these principles. They're psychological, really, have been applied by folks in the graphic arts to make sure that visualizations, graphs, charts, things, um, are accurate and reflect information. So we'll just go through this real quickly here. The law of closure: the mind automatically fills in gaps. Um, um, so that can be um, a problem, and it can be a great benefit. Um, the law of common region: when you surround objects with anything, a square, you'll see that, and you put them in a common region, you assume they have something in common. Okay, and that's one thing you can do in a PowerPoint or an infographic or a Tableau or whatever, is just draw a square around objects that you want to be seen as similar. And then this is one we've always seen. Um, Normally, you look at the foreground first, um, but this perception is one that we often see. Do you see a candlestick in black, or do you see profiles of faces in white? Um, so again, yeah, these are good principles. We're not even going to discuss these. There's not even room. But it's good if you're talking about visualizations in any depth, or doing any research into visualization. It's good to know these. Um, so so yeah, here another proximity is, similar objects grouped together. Um, make them seem more, more distinct, more similar. Um, See that these are in the mind. Um, it's the way you perceive things, and this is going back to human evolution. Okay, and here's lots of links if you want to learn more about it. Uh, here's here's more similarity. These you're going to assume the white circles have something to do with each other, and you'll often see that in a um, using um, uh, different symbols in a scatter plot when you have two different variables. There's a lot of that sort of stuff. So anyway, yeah, Gestalt principles play into data visualization. So you might want to read this web page and look into it more if it pertains to your professional world, or it might pertain to your dissertation research project. And then this guy Tuft is a little newer. And again, guys, I'm not necessarily a data visualization expert at all. But check out this website. And there's another, in addition to Tuft and Gestalt principles, I put a link in there to a TED Talk video about misleading graphs. So here's an interesting one. This um, uh, goes by year. We're starting in back here in 1978 and moving forward to 1985. Um, and it talks about like federal standards for automobiles. We have increasingly demanded that auto manufacturers make their cars more fuel efficient throughout the years. And this shows that in 1978 it was 18 miles per gallon, right? Okay. And then as we come forward in time, it went from 18 to 19, 20, 22, forward, up to 27 and a half in 1985, which I know is before most of you were born. But look at the relative, it it's showing a journey, yes, but look at the relative size of the 27 and a half. That's what this author is getting at. The difference between 18 I beg your pardon. The difference between 18 miles per gallon and 27 is overrepresented. It This would have you believe that between 1978 and 1985, only 7 years, um, that we expanded or demanded, like 10 times as much fuel economy, and we didn't. So here you go. A change of 53% is represented by a graphical change of 783%. So just yeah, be careful. Um, Data Inc. Um, yeah. So labeling, uh, labeling your graphs, data to ink ratio. You don't want to be too cluttered. Uh, Chart junk. uh, make sure your charts aren't too cluttered. Um, there you go. Yeah. So check these out. Uh, if you're in the visualization world, oh yeah, yeah, that's a lot to absorb. Um, okay. So Tufts principles. You can check out this link and maybe it has some use for you. Um, get rid of that. Get rid of that. And then switch to Chrome for Gestalt and Tuft. Yeah. So you will see in the academic uh, literature references to these and other principles and theories that are are being tested and all the time. Beg your pardon. Um, um, so working them into your dissertation is absolutely appropriate. This is a large part of data analysis, data science is visualizing the result. Okay, so I just got had some other what I think are interesting. I've seen this many times. Um, uh, you'll be shown in the U.S. The election results, which red is Republican and blue is the Democratic Party. So the two major political parties in America. And looking at this, I have seen it proposed that America is, overwhelmingly Americans are overwhelmingly Republican leaning. Um, and then you see this map. Look at all the red. These are counties actually in each state, um, or the 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 border of these shapes um, are counties, and these individual little dots are individual counties. Um, and this will be shown proving that Americans are overwhelmingly Republican. But then here's just a heat map of population density, and this is where the people live. The people, okay. This would be as if the earth itself, as if the ground itself voted. But we all know that people cast votes. So where the majority of people live are going to be, that's going to reflect, how people vote. So yeah, if you look here, this blue right here is Metro Chicago. This blue here is Metro Seattle, Tacoma, Portland, Oregon, LA, San Francisco, which are population centers. The um, Washington to New York, Rhode Island, Connecticut. This um, this blop here. So this just reflects, where people live and where people vote, and so it's misleading, is what I want you to. It's a misleading representation. Detroit, Detroit, Atlanta, Atlanta. So actually, as we know from the 2016 election, more individual people voted for Hillary Clinton than they did for Donald Trump. So interesting dynamic of what's going on in politics in the United States today. And then I found this a visualization. I thought this was interesting. This is the example of a heat map, which uses generally, green, yellow, red being the hottest or most dense um, of a thing, of an activity, of a variable. And this one shows where the human eye is drawn on a website in particular. And generally, the human eye is drawn to the center and the top left. In the US, that can be different in languages that are written right to left. In the West, the languages are primarily left to right. So starting out in the center and then immediately going to the upper left is where the Western human mind goes, and in this heat map. But that's another thing that, I mean, you got to look at where the data is coming from whenever you look at anything like this, polling data or uh, user perceptions of anything. It matters where that study population, what culture matters. And then you'll see network maps, and this can be this is air routes. The the size of the bubble is the number of daily flights, and then they've just segmented the colors by longitude. So I don't really know how necessarily how useful that is, but it shows you uh, um, the major air centers. Um, you know, South Africa, uh, huge in India, Asia, North America, and Europe. Not so much Africa, not so much South America, um, even though they are fairly populated. So there are things you could derive about economics and accessibility and whatnot from data like this. But I just thought it was an interesting visualization. And it can be web traffic, internet traffic. It can be telephone calls. You can visualize network maps like this for immigration, where people are moving from in the world and where they're moving to. Um, that's always an interesting statistic to look at is what countries are losing the most amount of people versus which countries are growing because of immigration. So yeah, just interesting examples of data visualization. And then this next slide, I wanted to show you, I uploaded, if you have Tableau, you can download a demo if you don't, and get to know it a little bit. It's a lot like Excel, really. Um, but yeah, if you want to download Tableau, there's a dashboard file, a workbook file in the classroom this week that you can look at. So this is another thing a colleague pointed me towards. These are Tableau dashboards. Now, actually, what we are looking at in Tableau is called a story. This whole thing is called a story. Each frame in this story is called a dashboard. And then a dashboard can be made up of workbooks, which are kind of like an Excel sheet. A workbook is kind of like you can put a visualization out there, you can put a data table, and then you can combine workbooks onto I'm sorry, worksheets onto um, dashboards. So you can have multiple worksheets on a dashboard, and then you can have multiple dashboards in a story. My phone is listening to me. This is unnerving. um, I'm going to pause recording for just a second. Okay. As I was saying, that's the way Tableau breaks things down. Um, Worksheets can be combined to make a dashboard. So you can present your user with several different graphs that are relevant. Um, and then you can combine dashboards into a story. Okay, so here's the introduction to the story. See a lot of dashboards, but there should be mistakes. There are mistakes. So this is it would be good for you to download and install Tableau and pull this up. It's a good way to get started with Tableau. Um, Here's a first mistake is fragmenting information, and and they talk about scrolling. See, you've got problems with you've got sales up here by category. The scale of this map is way over here. They're making you scroll through data, so um, yeah, so there's mistakes there, and then they tell you the mistake, and then the next dashboard corrects the problem. See, now we can see everything, um, and we we see the scale a little closer, and we're talking about orders. Now, I want to see which, okay, look, watch the map. See the change in profitability. Um, Texas is now more metric. This is called a tooltip when you hover the mouse over. Tableau calls this a tooltip. Um, so Texas's profitability metric was 54,000. California's is 28,000. But when we looked at orders, California had a lot more orders, 360 orders compared to 227. So this is an example of interactivity in Tableau. So these tooltips are helpful. So if you are a Tableau developer, this is probably all super easy. But anyway, there's a lot of good information in this file. There's individual worksheets. Um, the common mistake story is what we were on. So there's all these different worksheets along here. And then if you go along the story, it's almost like a Tableau tutorial. Um, Inadequate context. Yeah, here's another visualization issue. 66 to 76 what? Miles per hour, kilometers per hour. You don't, there's context. So this goes through just a lot of visualization best practices, which are, uh, widely available. I just wanted to show you this one. Okay, so that's Tableau. Check it out. I put this file on the classroom. No, I don't want to save my changes, but I did want to go to Python, which I play around with Python using the web-based interface called a Jupyter Notebook. If you're not familiar with these, um, you probably want to get familiar. You're starting to see them more and more, and you can do Python or R if you have R installed. Um, you can do a Jupyter notebook in either language. But what I have to show is Python. I did want to show a couple of visualizations. It's incredibly powerful for a scripting language. The Python um, uh, community, open source community, has written all these fantastic libraries. So I just wanted to show you here's an example of a Jupyter notebook. Very, very short Jupyter notebook. This is a code cell, and you can go into the cell and say clear the output. So this is what it looks like when you first bring it up or when you first start writing this code. And these are libraries. Seaborn and Matplotlib are functional and analytical libraries that you can bring in. And then the actual command is one line. Once you set up your parameters for how you want things to appear, and you get your data uh, um, lined up, the actual visualization is one line of code. It's crazy. Look at this. This is all straight line code. There's no looping, no repetition. So if we run this, takes a few seconds to import the libraries and to interpret. Python and R are both interpreted languages, so they're not particularly um, fast. So doesn't look like I'm getting my visualization. I ran this before and it worked like a champ. Well, I'm glad that it was there when I came in here. I would have to go in now and troubleshoot this thing, but I don't know why it wouldn't be working. Whenever you see this is the sequence of these cells. as they execute in a Jupyter notebook. So this is Python code, but we could write another code cell here. Yeah, so it's working. I wonder why my plot didn't work. Huh. Because it's this SNS.violin plot is the command that actually runs um, to create that. I'm going to run that again and see what happens. Bam, there we go. Huh. That was really weird that it didn't show up before. But anyway, a violin plot is another data visualization that's very close to a what do they call that? A box and whiskers? Yeah, that shows you the the basic statistics of a data value of like a column in Excel, where it shows you the mean, the median, um, the first and second, the quartiles, and how skewed the data is by how long the box with the whiskers are, and these violin plots are similar type of representation. But anyway, this is Python. If you've never seen Python before, this is the Anaconda. I use the Anaconda distribution of Python, and it comes with several really cool tools, um, to include Jupyter Notebook and the Spider IDE, integrated development environment. If you're writing kind of interactive, descriptive code in Python, a Jupyter Notebook is really cool because it lets you document what you're doing as you're doing it. I'll show you that here in a minute. But this is Anaconda, and I wonder. I thought I had it set up where I could create either a Python or an R notebook, but for some reason it doesn't appear to want me to want to let me do that, unless I run this one, Jupyter Notebook R tutorial. I apologize. Stand by. Um, I've got some other notebooks in here. Whoop, there comes a Jupyter notebook, and ha! There you go. I know what I'm doing wrong. I have two environments set up. One is strictly Python, and the other is both. So here I could. I don't program in R. I don't know it. I know some Python by memory, but you can set up your Jupyter notebook so that it pulls up either either type. So I need to go into my start menu and get rid of that other one so it pulls this up if I ever want to do some side by side comparison of R, which is something you'll need to do this week. Let's see here. I got some more notebooks I wanted to close. I just closed that tab. I think I got some plotting. Yeah, let's try this one. Plotting one. This shows some visualization. What I want to do here is kill all output clear, so that we're running these from scratch. Yeah, here's a good. And if you guys are Python programmers, I can share these notebooks. These come from a colleague of mine that teaches Python at the university. So we run this, see what we get here. Ha! The Anscombe data set, which is a kind of a sample data set that shows you the difference between mean, median, mode, and why you need those different measures. And again, here's that importing that Seaborn library. And you can rename it so it's a little bit shorter. SNS is um, an accepted Python abbreviation for Seaborn. And then um, here we can run matplotlib. Matplotlib is another one. That's what we used earlier. And then we want to run renaming the data set. And if you just type in the variable, it prints it. You don't have to say print, variable in Python. It's powerful and it's scary. I don't know. Let's see if we can do a basic plot here, and then we run this one. That didn't give you much. That doesn't do much for you. But there's a scatter plot that's starting to give you a little more, um, a little bit more. Anyway, just some sample Python. And one thing to note in Jupyter notebooks is this. See how it looks like a web page with code cells? Well, these are actually cells also. They're markdown cells. And if I double click on it, it shows you it's kind of like HTML tagging, the markdown language in Jupyter notebooks. So this allows you to document your project and publish it. And since the code is right there, it allows someone to repeat your work, repeat your experiment, repeat your data analysis themselves, and they can change the code around if they see some sort of assumption or something that they want, or if you're publishing a model and they want to adjust the parameters of that model. But if you if you click in the plot in the markdown cell and hit run, it renders it for you. So yeah, that's one, but it's not the best. Let's see if this will run. Sometimes it requires a library, yeah, that I haven't imported yet. Matplotlib or plot. Anyway, I'd have to, if you run these cells in order, he imports libraries, and once you do something in a cell, it stays active for everything in the Jupyter notebook. So I'm spending too much time on this, guys. Get back to the presentation. So I did want to talk about your residency weekend, which is coming up in 2 weeks. It'll be Friday evening, October 2nd to October 4th. Next weekend, the weekend of the 20, whatever, 6th, 25th, I'll post more information about the residency to make sure you're ready. But as you know, 2 weeks from now, you're getting ready. You got to have reliable internet and a camera. I'm going to have to take. I'm going to have to see photo ID. You are welcome to mask any privacy information, but your name and your picture needs to be on a photo ID. And then they're uncomfortable. You don't want to wear them all day. But I beg you for the residency weekend to have a boom microphone and headset, um, similar to what you see me wearing, and you hear me every week. My videos are nice and clear, right? Nice, clear, crisp audio. Um, when you use the microphone um, on a laptop, it sounds like you're in the bottom of a barrel and you're talking and it echoes, and some are better than others, but generally speaking, none of them are as good as a headset boom microphone. And I bought one for $20 yesterday at Walmart, a USB headset boom microphone. I beg you, you will have a speaking role in the residency. I can't force you to have an external microphone, but I'm begging you to. Okay. During the residency, we will have 3 assignments. You'll turn in a paper. You'll present that paper. So you'll turn in the PowerPoint behind that paper. Um, and then every course you do a practical connection assignment where you connect what you are learning or will be learning to your professional world and your dissertation journey. I've had massive problems. The practical connection assignment is probably the easiest assignment, but students have historically not worked on it until the residency and waited till the last minute. And then I see people turning in stuff that they did for another course, or claiming that 5 weeks into this class they're now an expert in R programming and have completely revamped what their workplace is doing, and they're just not honest. They're just not real. I keep using the term real. Be real. Be for real. Um, so anyway, you'll turn those 3 things in, and that's 60% of your grade. So I have a survey in this week's folder. I have some latitude with this assignment. Not I don't with the others necessarily, but would you all rather um, break into groups of 5 or 6 students and write a research paper that's going to be like 7 pages or so on a topic I assign, and it'll be a data analysis topic, and you'll have to do a literature review like I've posted about this week, or this past week. Or would you rather work on individually? So you will write a dissertation, a research prospectus, and you'll talk about your research prospectus individually. There are about 15 of you work in this class, so we can do this. We can do individual work, which is good and it's bad. Some people hate group papers. Some people like group papers. Some people like group papers because they like working in a group. Other people like group papers because they like to hide within the group and they don't actually, you know, uh, 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 contribute anything. Um, so, uh, so there you go. There's a survey. Let me know what you guys think. Okay, so the discussion this week, again, back to um, the week's topic is um, um, visualization, but the discussion and this discussion is assigned by the university. I don't have latitude in that. Is really more about Python versus R. So let's see what you got to say. And I will beg you again, if you're getting poor grades in your discussion, it's because you're not being real. You're trying to post something that looks like real discussion, but it's not. Um, you know, talk to each other in the discussion board. Don't just hit reply and say, I want to share my thoughts, blah, 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 and then a lecture. It's not anything personal. It's not anything, that you really think. It's something that you're reading off of a website, and typing into the class discussion. Share your real personal professional insights. I did a professional development seminar of sorts this week about engagement and being engaged with your students, the students being engaged with you, um, and the students being engaged with each other, engagement. And it requires a level of genuineness, a level of authenticity. You got to be for real. to be engaged. And that's what I'm not seeing in large part with this course or any other course I've taught for the University of Cumberland's. It's a whole lot of fake comments, fake papers, fake. And I'm just trying to get past that. It breaks my heart when I see you know, people faking things that they're not. Their brain didn't really come up with it. Um, so I I really hope that we can change that. And another indication is I ask you guys questions in your papers and you don't answer them. You don't email me back. I am engaging. I'm not being rhetorical. In this online environment, when you ignore someone, uh, they automatically, their mind goes that you don't care, you're not engaged, and that's what happens when you guys write me a question. One of you guys wrote me a question and wanted me to answer that same day, but yet you hadn't answered my email from the beginning of the class. And that's the kind of thing that just kills a good professor. Some of your professors may not care. But when I ask a question, I'm looking for an answer. When you ask me a question, you're looking for an answer, right? So be engaged, guys. This is real. Take this seriously. Uh, treat it treat it appropriately. All right. Well, that's all for this week, guys. Just stuff on visualization um, and R and Python, and you got a little bit of a minor, teeny tiny walkthrough on Python, and then my other video talks about R programming, and a colleague of mine that works in the environmental data space. Okay, all right, guys, have a good week. I'll see you in the class discussion.